Welcome friends to my YouTube channel. Now on last lecture I have told about the corrections made in Poisson's equation. Okay, acceleration and kinetic energy corrections to Poisson's equation, and we have rectified the equation. Okay, now in today's lecture I shall going to discuss motion of a body falling through a viscous medium. Okay. Now suppose an object of mass m is moving through a viscous medium, say of viscosity eta. Okay. Now what happens if an object passes through a viscous medium? Okay, then obviously on the object there is a downward force mg, obviously. Okay, so if m is the mass of the object, then mg is the downward force on the object. Now a viscous force acts in the opposite direction of the body. Okay, let this viscous force is f. Okay, so this is the resultant, and since mg is greater than f, the resultant motion will be in the downward direction. So this is the equation of motion. Okay, here x is the displacement. Okay, so the downward weight of the object is mg, and a viscous force acts in the opposite direction. Okay, and their resultant is this mass into acceleration. Since mg greater than f, the resultant will also be in the downward direction. Now what happens in general? Viscous force is proportional to velocity. Okay, the viscous force is proportional to velocity. That means what we can write, that is here we can write this. That means k is a constant, k multiplied by k. Okay, so k is a constant. So now we have to put this value of f in this equation, and we have to solve this. Okay, so let us see what the result comes out. Now the downward force is mg, and the expression of viscous force that we obtain is kv, and that we can write m into d2h dt2. That means we can write also dv dt. Okay, so if we divide this equation by m, so what we get? G minus k by m into v, that we can write as dv dt. Okay, so just rearrange it. dv by g minus k by m into v is equals to dt. Okay, now let us assume this as z. Let us assume this quantity is z. So g is constant, so we can write minus k by m into dv is equals to dz. So what we can write? We can write dv is equals to minus m by k into dz. Okay, so if we substitute the value of dv in this equation, so what we get? If we substitute the value of dv, so what we can get? We can get minus m by k dz by z is equals to dt. Okay, or we can write dz by z is equals to minus k by m into dt. Now if we integrate this expression, so what we get? If we integrate this expression, then what we get? This is simply ln z. This equals to minus k by m into t plus c, integration constant. Okay, now what is the value of z? That we assume as g minus k by m into t. This equals to minus kt by m plus. Now we require two boundary conditions to find out the value of C. Now what are the boundary conditions? Now when initially, that is at t equal to 0, the object is at rest. That means at t equal to 0, v equals to 0. So what will be my C? If you put this condition in this equation, my C will be ln G. Okay. Now we have to substitute the value of C in this equation. So what we get? If we substitute the value of C in this equation, so what we get? This is simply ln G minus K by M into P. This equals to minus KT by M plus ln G. Okay. Or ln G minus K by M into V by G. This equals to minus KT by M. So what will be this? G minus K by M into V by G. This equals to e to the power minus KT by M. Fine. Now what will be this? G minus K by M into V. This simply equals to G into e to the power minus, the marker is almost finished. Okay. So we can write this expression. Now if we simplify a little, okay, so my K by M into V is equals to G into 1 minus e to the power minus KT by M. Okay. Now what will be my V? Mg by K into 1 minus e to the power minus KT by M. Now if you look closely to this equation, then we can see that with increasing time, e to the power minus KT by M decreases. That means with increasing time, this term decreases and we can almost ignore it. So with increasing time, velocity almost attain a constant value. Okay. With increasing time. Okay. As the time increases, the exponential term decreases and we can neglect this term. So V is mg by K. M is constant, G constant and K is constant. So V attains a constant value and this is known as the terminal velocity. Okay. So from this theory, the concept of terminal velocity comes. Okay. So with increase in time, the exponential term decreases. Exponential term decreases and V attains a constant value called terminal velocity. Okay. So this is what about terminal velocity. Okay. Now we will understand the concept of terminal velocity in Stokes law chapter more accurately. Okay, so this is the mathematical concept from which mathematical theory from which the concept of terminal velocity comes. We will clearly understand it on our next lecture, that is on Stokes law. Okay. So as soon as the time increases, the body attains a constant value, which is called constant velocity, called terminal velocity. Okay. So So this is up to what today. So if you don't subscribe my channel, then kindly subscribe it to get latest videos. Okay, and in our next class we will understand more accurately the concept of terminal velocity. Thank you.